Hey, welcome back. In this episode, we're going to talk about Docker Swarm and how we can use Docker Swarm to orchestrate our deployment of our application to Amazon EC2 instances. So let's get at it. Okay, before we dive into the technical details, let's take a high-level look at what we're talking about. First of all, what is container orchestration or just orchestration? And I use ChatGPT to generate this response, but generally what you're going to see here is orchestration is a combination of tools that allow us to deploy, scale, network, and just manage the lifecycle of our applications. Remember, using Docker, we have Docker images. So we have a Docker image that has our application contained, say it's version 1, and we can use Docker to take that image and create a container. And the container is a running instance of that image. And so far that process is manual. I can use tools like Docker build to build the image. I can use tools like Docker compose to kind of orchestrate my local environment and build the whole kind of stack that I need. But in a production environment, we want something more hands-off. We want a tool or tools or tooling in general that kind of helps us orchestrate the deployment to our different nodes. We're going to run this on Amazon AWS, so we're going to spin up a number of EC2 instances that we can use for our Docker Swarm cluster. And I understand that Amazon, for example, has ECS and EKS where they provide us a service around all of what we're going to do. But this video, we're going to cover what if you don't have access to that service? What if you just have some Ubuntu instances and you're going to create a cluster and use Docker Swarm for those instances? So how would you do that manually yourself? And I think that understanding how you do it manually is an important step into being able to use, a service like Amazon ECS. So let's say we have these EC2 instances. One of the first steps is we're going to install Docker, the Docker daemon, on all of those instances. We're actually going to do that when we provision the EC2 instances using kind of the user data, which will show all the details a little bit. But that Docker daemon is going to be running on all of these different nodes. And so far, all these nodes, all 6 of them, there's 5 down in this row, there's 1 up here, they look exactly the same. Then what we need to do is we need to differentiate one of the nodes. And when that has to become kind of a manager node, and on that manager node, there's a bunch of tooling that helps us with the orchestration of all of our applications. And I just boxed that in and I called that the orchestration service. But some of the things that the orchestration service does is when we say, hey, we want 5 instances of our application running, it can discover where our application's running, see if there's 5 instances. It can understand if it needs to spin up any additional ones. We can have kind of lifecycle rules. So any instance is older than, say, 3 hours, shut that down and recreate it. And so there's a lot of different tooling that's built in to this orchestration service. The next step we do is we register all the other nodes as worker nodes. And those are registered with our manager nodes. And so then when you ask it to deploy an application, it can generate these containers. And these containers are going to be deployed to the different workers. And one small caveat is that this manager node typically is a manager/worker, so it kind of serves dual purposes. So the topics that we're going to cover in this particular video on Docker Swarm is we're going to create those EC2 instances with Docker already installed. I'm going to show you how to configure the Docker Swarm master and the worker nodes. So we'll set them up so that we know which one's the master, which one's the worker. After that, we're going to start talking about how can we deploy our containers or our services to these different worker nodes. So we're going to start with a manual deployment. So we're going to use command line and we'll deploy an application. And then we'll also manually kind of scale it, and just so you can see kind of what it looks like. Then we're going to start to talk about stacks. So Docker Swarm has this concept of stacks. And if you're familiar with Docker Compose uses YAML, and the Docker stacks that are part of Docker Swarm use that exact same YAML. In fact, what we're going to end up doing is we're going to supplement our Docker Compose file with a few additional tags or elements so that it has some additional capabilities that Docker Swarm can take advantage of. And so we'll see that when we start talking about stacks. The next thing is we're going to introduce kind of a monitoring service so that we can actually visually see where our application containers are deployed to on each of the nodes. Because remember, we're going to have, say, 3 or 4 nodes, and our containers can be deployed across those different nodes. And the next 2 topics are going to cover some kind of common maintenance type things. So let's say I have a node that I need to run an update on. I'm going to drain off all of the current applications or containers that are running on that node. And once they're drained off, I can update that node. And then after I've done that update, I can set the status of that node back to active so that any future updates will incorporate that node also. Another common task is, what happens if my application goes from version 1 to version 2? It's a pretty easy thing to deploy a rolling update, and Docker Swarm can help us kind of control how that update is deployed. So we'll take a look at that. And then the last 2 bullet points are more of a discussion. What are some things we need to consider if we want to deploy a high availability Docker Swarm cluster? And we'll talk about those. And then finally, we'll just wrap it up with a quick discussion about other orchestration options, which we'll cover in future videos. So with that said, let's get to that first bullet point and let's create our EC2 instances. All right, so I've already logged into my Amazon AWS console. So I'm on the console homepage. What I'm going to do is I'm going to go over to the EC2 panel. So I can search for EC2 up here and we can quickly get there. Right now you can see I don't have any instances running. I do have some instances that are not running that are kind of old. I just want to keep them around, but they're in a stopped state. So right now, if I just look at all the running ones, there's nothing running. So the next thing we're going to do is we're going to create a number of EC2 instances and we're going to name them a little bit later on, but let's go ahead and launch a new instance. And over here is our option to create the number. So we are going to create 5 of these. And one of them is going to be the master/worker, and the other 4 will just be workers by themselves. And for now, we really don't have a distinguishing name for these things. So I'm just going to go ahead and let's call this our Swarm cluster. And it'll add that name in there. I'm going to just keep the Amazon Linux distribution here. So we're just going to keep that. For our instance type, I'm going to keep it a T2 micro. So we're going to have 5 of these T2 micros, and they're going to be running the Amazon machine image for Amazon Linux 2023. I do want to be able to SSH into them. So I have this key pair that I created earlier. I'm going to go ahead and use this Laravel demo key pair. For the network settings, I'm going to edit this. I have already a VPC that I've kind of built up for this Laravel demo. So this is kind of associated with that Laravel demo. So we're going to use that VPC. For now, we're going to stick these all in kind of the Laravel demo public subnet number 1. It's going to automatically assign a public IP address to them. This launch group, I'm just going to use my, misspelled that. Let's go ahead and take that, correct that real quick. I'm going to go ahead and just use my name. And this will be the launch wizard. I'll take that name and just put it in here too. So for the security groups, we need to open a couple of ports for Docker Swarm to use for communication. All right, so to figure out which ports, if we go to the Docker docs themselves, so this is under Docker docs and then engine/swarm/swarm tutorial, you can see as you scroll down the open ports. So we need 2377, 7946, 4789. This one technically only needs to be open on the manager nodes, but we're just going to create all of our nodes so they're exactly the same. So we're just going to open it up for them all. So let's go ahead and set these as they're open. I'm going to keep the SSH because I want to be able to SSH in if I have to. So we're going to add another security rule, and this is going to be for that 2377, and this is just custom TCP. All right, so this 2377 rule, if we look back at the information here, this is communication with and between the manager nodes. So all of those nodes are going to be deployed into this VPC. I can use this CIDR block as my kind of source for information. So we're going to set that up right now, 10.1.0.0/16. So that's our CIDR block. So this new rule then should open that port for anything inside our current VPC. And then I have port 7946. And again, this one is an overlay. So it's no discovery. It's within our network. So we're going to add another security group here. Port, that's the port. And we're going to add our same CIDR block. And then the final port is this 4789. And again, that's inside the VPC also. It's custom UDP traffic, it looks like. So these were TCP, TCP, and UDP, and this is UDP. All right, so those are the 3 ports that Docker needs for the orchestration. So to talk between the different nodes and the manager node. We also have a web application here. So I'm going to go ahead and expose port 443, which is HTTPS. We're going to expose that from anywhere. And I'm going to add one more for just HTTP traffic from anywhere. Okay, so I think I have the security rules that I want in place, and just to kind of scan them one more time, SSH, so we can manage the instances themselves, we can log in. The next couple of rules are for Docker to communicate between the different nodes and the manager node. So there's 3 ports, 2377, 7946, 4789, which correspond to these 3 ports that have to be open. And then the last 2 nodes are for our application to be exposed. So we're going to keep those all the same. Everything else down here, we're going to keep the same. Under advanced details, then this is where I want to scroll all the way down to our user data, which is our option here. And I've just got some code. I'm going to copy and paste this in. But essentially, this is going to do an update on our system. We're going to install Docker. We're going to start the Docker service. We're going to add a Docker user, and we're going to install Docker Compose. So when this is all done, then our EC2 instance should have the Docker daemon running. And then finally, over here on the right-hand side, as we already indicated, we're going to create 5 of these things. So we're going to go ahead and launch these instances. And if I come back to our instances panel, let's see, pending. So I got 5 that are pending. We're going to let these spin up. So let's let these work for a couple of minutes here. We'll come back when it's all said and done. All right, so next task is we have these 5 nodes running. At this point, they all look exactly the same. There's not really a manager and then workers. They're all exactly the same. So our next step is let's go ahead and designate one of these as a manager. So I'm just going to put this as our swarm manager. And then all the other, I'm just going to name these. Nope, that didn't take. Maybe I have to. So try that again. Click the accept button. There we go. Let's do it that way. So all the rest of them I'm going to name as worker 1, worker 2. Okay, so I've got these kind of named. They're still all the same. They just have different names now. So the next thing is this is running. It's still initializing, which means it's probably running through that user data script. I'm not so sure that Docker's already installed. So let's do one more pause here and let these things get completely up and running. Okay, so after just about 30 more seconds, all of them are running and we have these checks. Okay, so the next thing is I want to log into the Docker Swarm Manager and actually run the init command for Docker Swarm so that becomes the manager node. So we're going to select this. So this does have a public IP address. I have the SSH key already for it. But what I can use is under our actions menu, I can use connect to actually do a connection to this Docker Swarm. So instead of running my own SSH shell, I'm just going to use the built-in EC2 one. So I'm going to run connect on this. And now I have a window open for the terminal window for this node. So again, I am on this Swarm Manager node. That's what this window's for. One of the things I do want to understand is when I click on the Swarm Manager, it has a public IP address, but it also has a private IP address, which is right here. I'm going to go and copy this private IP address into the clipboard. And the command I want to run is, first of all, let's go ahead and see if Docker is running. So Docker is installed. So I just typed in Docker, I hit enter, and you can see that Docker is definitely installed. So that's good. So that means my script that I ran earlier on the user data has correctly finished. And what I want to run now is Docker Swarm init, because it has multiple IP addresses. I want to actually set the IP address to this private IP address that I just copied. And what that's going to do is it's going to start Docker Swarm, and it's going to designate this as the master node. And so that's a very quick command. It says swarms initialized at this current node. It's now a manager. It's also a worker, so it's okay that it just says it's a manager/worker. And more importantly, it's given us this command. So this is the command that I need to run on the other nodes. Docker Swarm join, and then it has this token. All of this here at the very end is kind of a token, and then there's an IP address, which is the IP address of the master node. Okay, so with that said, what I'm going to do is, for our worker number 1, I'm going to create another connection. I'm going to open this in a new tab so I can have these open. This is a terminal window into our second Linux instance, worker 1, and now I want to run this Docker Swarm join command. And then again, pretty quick, now it says this is joined as a worker. I'm going to repeat that for worker 2. And now it's joined. And we're going to repeat that for worker number 3. And I've got worker 3 has officially joined. And the last one is the swarm worker number 4. Okay, so now all of these have joined. All these instances, I do not need these connections anymore. What I'm going to do is just get back to our master node. So now that I've got the master node set up and I've joined all of our worker nodes, so now I can run a docker node ls command, and it will list all the different nodes. So I've got 5 nodes, 1, 2, 3, 4, 5. One is designated as a leader. You can see, here's their IP addresses. So at this point, we have our infrastructure set up for our Docker cluster or our Docker swarm. And so the next steps are to kind of learn some of the orchestration tooling or commands that we can use to create containers on this cluster. Okay, so at this point, our infrastructure looks like this. We have the manager created, we have a bunch of workers created, and we have this orchestration kind of service set up. Let's manually orchestrate some applications. So once again, we can see our manager and our 4 worker nodes. I already have a console opened up for our manager node. So this is 10.1.14.224, which is the manager IP address. So we have a console already connected up. What we're going to do next is we're going to use Docker Swarm to run a single instance of an Nginx web server. So I'm going to copy and paste this command in here. So this command is using the Docker daemon, and we're going to create a service, and we're going to call the service web_app. We're going to start the service off with 1 replica, and we're going to publish port 80 on the outside to port 80 on the inside. And right now I'm using this image from Nginx demos, and what this image has is it's based off Nginx, but its default page is set up so that it shows you kind of the host name and the IP address. So I want to be able to hit that default page and see which node that request was serviced by. So we're going to hit enter here, and it's going to go through some gyrations. This is part of the orchestration now. So we aren't controlling which node that this service gets installed onto. So we have a container running somewhere, but we're not controlling any of that. All we're doing is we're saying, this is the state that I want to be in, is I want to have one service running. We name this thing called web app and make that happen. And so you can see it's kind of gone through a couple of things where first of all, I had to download any layers from the image, and then it's kind of trying to ensure that the state that we've asked it for is matching the state that we have. So we have one instance running, and there is one instance actually running. So a couple of commands here now. We have Docker service. If you just hit enter here, you can see kind of the usage. So there's ls, ps, rm, rollback scale. So we're going to use a couple of these in a little bit. But for now, let's do Docker service ls. We can see all the services that are running. And we just have this one service called web_app. We can see that the ports exposed are port 80 to port 80. So now if I go up into my IP address and I open this, and again, I don't have an SSL cert, so I'm gonna have to get rid of the S here. So it's not HTTPS, it's HTTP, and I'm gonna end up hitting that endpoint. I'm gonna slide this one down here. So Docker under the hood is doing some load balancing for us automatically. And I'll show you what I mean by that is right now, this is the IP address of the master node, which is right there, the manager. What if I grab the IP address for, this is worker number 1. And again, I have to get rid of the HTTPS, just make it HTTP, and I get the same response, right? So no difference whether I hit master node or hit worker number 1. And you're gonna find the same happens if you hit worker 2, 3, 4, or 5. All of those return the same response. So it doesn't matter what IP address I ask for. I'm asking for port 80, and it's going to hand that request to a container that can service that response or service that request, and then it's going to give us the response. Right now we only have one instance, and you can see that that instance is here. Part of the challenge is we want to be able to kind of visualize some of these instances and where they're all running. So I'm going to pull in a different tool. There is a visualizer that we can use to help us with this. So I'll leave the link to this in the bottom. But if we scroll down to this Docker Swarm visualizer, what you're going to get is we're going to get a nice page where we can kind of see, oh, there's 5 nodes. Here's where this container is, and we can see all the different containers. So I'm just going to scroll down to run in a Docker Swarm. We're going to copy this, and we're going to go back to our instance, and we're going to run that command. So just directly copied that from there. I might have an extra $sign. We'll see if that'll run. Yeah, so I copied an extra bash. Let's see. So I'll copy it manually here. I think when you hit that, it actually grabbed that $sign there. I don't want that. Just this bits. All right, so we'll rerun this. Might take a while to download all the layers that it needs for the image, but there is this Docker samples / visualizer image. It's pulling down. There's a couple of constraints. There is a constraint here where it's only going to run this on the manager node, so we're not going to get this more than one instance. It's exposing port 8080. While this is still starting, I will say that I did go over, and if we look at any of these nodes, and I look at the security group has now port 8080. I added that after the fact because I didn't realize that visualizer existed. I really wanted to be able to see that. So I exposed port 8080 to all requests. So anything in the public domain, if you ask for port 8080, you'll get this visualizer. Let's go on back here. Now this seems to be running. If I say Docker service ls, I should have 2 services now. One is named Viz, which it got the name from here, and the other is our web app. Port 8080 should now be available. So I'm just going to take one of these, and I'm going to switch to port 8080. Let's see what I get. Perfect. So now I get a list of the manager plus the 4 additional workers, which correspond to all of my EC2 instances. I'm one manager plus 4 workers. And then you can see that the visualizer is running on the manager node only. And then our web app is currently running on this worker down here, which has an IP address of 242. But the name of this, let's go ahead and pump this up a little bit and maybe make this bigger. The name here is B0D75B. So when I go to our Nginx page, you can see that B0D75B is the name. So no matter when I refresh this, I'm always hitting this container right here. That's the one that's servicing us. Now let's use another orchestration tool. We want to scale this service. So we have this web app, has one instance running. Let's go ahead and clear this out. So we use Docker service and when we use the scale command. And with this, we put in the name of the service that we want to scale, which we named it web app. And then we want to see how many instances of this do we want. I'm going to ask for 5 because I know that there are 5 nodes altogether if you include the master node that can host this. So we're going to scale up to 5. 1 was already running, you saw that, and then the other 4 came online pretty quickly. And it's still trying to verify that it's converged to what we've asked for, and at the very end it says, okay, we have converged. If we look at Docker service ls, we can still see that we're just getting the 2 services, Viz and web app. If I go to our visualizer though, you can see the visualizer already up to date here. On the first node, which is the manager node, we have an instance of Viz running and we have a web app running. All the other worker nodes, all 4 of these, have an instance of web running. Now if I go to my Nginx, so I see a 200 DCE, 200 DCE. So if I go to see which one that is, that's this one right here. So far we've seen this worker. And what I want to do is I want to refresh it and let's see, and we'll just kind of go from left to right. So master, and then this is 1, 2, 3, and 4. So we've seen number 1. If I refresh this, I get a new number. This is DCFFE. DCFFE is number 2. So we've seen 1 and we've seen 2 so far. If I refresh it again, now I got B0D75. That is B0D75. That's this worker here, so that's 4. We haven't seen 3 or the master serve up this request yet, so let's refresh it again. I got 11A928. 11A928. That's this node. So now we've seen the 4 workers. What I want to see next is I want to see the master kind of contribute to this. That's 889E4. So let's refresh it again. 889E4, which is the master node. So every time I refresh this, under the hood, Docker is kind of doing, it looks like what is a round robin, essentially, and I'm getting a response from each of those different nodes for me. And as I just refresh randomly, I do see that it's not changing all the time. I don't know if this Nginx has some caching configured or not, but it does at least balance the load between our 4 workers and our 1 master node or manager node. A couple other commands that we can try. So if we look at this Docker service again and I hit enter, there is a PS command which says it lists all the tasks of 1 or more services. So let's go ahead and say Docker service PS and hit enter. It says at least 1 argument and we have to put probably the service name. So we'll do web app. And here we can see I have 5 instances of this web app running on the 5 different nodes, right? So the master and the 2 the workers. And that's the same information that we're getting from this visualizer. So if the visualizer is not installed, you can use this Docker Service PS web app to see which nodes everything is running on. All right, and the last thing I want to do is, obviously we can scale up. We did that scaling already, and we can just set the number here in the scale. And we can scale up to 10, 20, whatever we think is appropriate. Now, obviously, when I scale to more than 5, so let's just put, let's scale it up to 8. So it's going to see that 5 of them are already running, and it's going to start 3 more right away. Now it's making sure everything's kind of stable and converged. Once it's converged, it'll let us know. But if I visualize, I didn't have to refresh here. Now I can see that my nodes, I have the master node running 1 instance of the web. I have worker 1 running 2. Worker 3 is running 2. Worker 4 is running 2. And the last worker, I guess 1, 2, and 3 are running 2 instances each. And this last worker, number 4, is only running 1 instance. So you can see altogether, I end up with my 8 instances, and it's distributing it however it feels like it needs to. And the final thing I want to do right now is I want to show you how to shut things down manually. So we know right now I can come in here and I can scale up and scale down. I can rescale this all the way down to 1 if I want, or maybe to 2, it doesn't really matter, but then it'll kind of scale down, it'll converge, everything will be there in their visualizer. we'll start to see that now I only have 2 instances running. But if I just want to shut everything down, I can use the Docker service rm command, and then I can say, well, I want to remove all of the web app. So then if I look and see what services are running, the web app is no longer running. If I go under here and try to hit my Nginx endpoint, this errors out. I don't have a port 80 anymore. Obviously, I still have this visualizer running, and you can see it's running on port 8080 over here, but I don't have any web apps. So finally, what I'm going to do is I'm going to remove the visualizer, the VizWeb app, and at this point, this should no longer work at all. So that's the way I can do this manually. But the next thing I want to look at is how can we do this via some code. So some infrastructure as code, so I can help define, what my environment really should look like. So let's take a look at that next. Okay, so now let's start talking about stacks. So in the context of Docker Swarm, a stack is very equivalent to like our Docker Compose. If you use a Docker Compose, you can compose services and you can show Docker Compose, what ports they expose and mappings of kind of the volumes and all of that content. All right, so let's take a look at the Docker Compose file that I have here. So just to orient everybody, so I am still logged into the master node. And if I print my working directory, I'm in the EC2 users home directory. And if I see what's all in here, there is just a single directory called app. So I'm going to switch into that app directory, and I'm going to look and see what's in here. There is a Docker Compose file. So I'm going to use nano just to look at that Docker Compose file. So this file, if you've used Docker Compose, will feel very familiar. So under services, there is one service called web, another service called visualizer. Normally when we use Docker Compose, there is this build component that I want to be able to build a Docker file from. So it's saying the Docker file, you're going to find it in our current directory. I don't have a Docker file here, so I'm not really going to use Docker build in this Docker Swarm environment. I'm going to use that on my dev environment, but this single file, this single Docker Compose file, can have attributes in here like build, which Docker Compose understands and knows how to use. And then it can have other attributes like deploy, which Docker Swarm understands and uses. This deploy attribute isn't used by Docker Compose directly. So if you're just doing Docker Compose up, it's not going to use this deploy attribute. That's for Docker Swarm. So if we look at the web, we have this web service that we're building. It's going to use, this is the image file that I had posted earlier. I don't control that image. I'm not going to build that image, but that is the image that we're using. I am going to go in here and I'm going to edit this to a certain extent. I want to be able to deploy a certain version. So I'm going to deploy 0.3. It looks like 0.4 is the latest version, so I'm just going to go back one version. I'm not sure if this is broken or not, but we'll see in a second. So that's the version I want to deploy is 0.3. I'm exposing port 80. I'm mapping port 80 outside to port 80 inside. I have this network that I've created here. The deployment attribute, I'm saying I want one replica. There are some other things in here that we're talking about right now, is when I go and I try to update my deployment, it will do 2 deployments in parallel, and then every 10 seconds it'll start another 2. So what this means is, let's say, and we'll test this in a little bit, I'm going to go from version 0.3 to 0.4, and let's say I have 5 replicas going. It'll take 2 of those replicas, it gets to decide. It's going to update it from 0.3 to 0.4, and it's going to give it 10 seconds. So after everyone it deploys, it'll do 10 seconds, just kind of pause there, and then it'll go to the next 2 and give it 10 seconds, then go to the next 2. And has a restart policy. So if you deploy something and it fails, it's going to try to restart it. Here's the visualizer. We created this visualizer last time, so we're just going to drop this into place. So this is the visualizer. It uses that same image that we saw, and we're using the stable version. And it's mapping port 80 on 8080 on the inside to port 8080 on the outside. And then there was a volume mapping and a constraint for only running this on the manager node. So that is our Docker Compose file. I just manually created this on this master node. Normally this would probably be in a Git repo someplace, and you would pull down this composer file into a place where you could use it on your master node. So for now, it is very manual. I just created this manually. I'm going to save my changes because I added that version in there. But again, normally this would be a part of a Git repo. So that we're going to pull that Git repo down. Let's clear this out and let's do a listing of our services. There should be nothing running because I just shut everything down. Okay, so we're going to use another new command called docker stack. And if you look at the options here, there's a docker stack deploy. If we look at the docker stack deploy help, so like it shows here, you can run docker stack, the command that you want in help, and it gives you some options. So the command that we're looking to run is docker stack deploy. The next thing I need to do is I need to provide the stack name. So we're going to just call this web app again. And then I'm going to point this to a compose file. So my Docker compose file is in this directory and it's just called docker-compose.yml. So when I run this command, this should now spin up all those services that are kind of specified in that compose file. And so you can see it's done that. It's created two networks, a web app and a default. I think that the web uses MyNet, which is the kind of custom network, and the visualizer didn't specify a network, so it's just using the default. But you can see these services now are all running. If I see what Docker services or service ls is, I can see my two services are running, web app and web. If we take a look at that Docker compose file again, I said one replica. So what I'm expecting is that if I go to our visualizer, which was broken from the last time, but if I refresh this now, this should now be working. And I should see my 4 worker nodes and my 1 manager node. I see the visualizer here, and then I see the 1 web app. All right, so let's go back to our Connect console, and we're going to modify the compose file. And in the compose file, what I'm going to do now is I'm going to set my number of replicas to, let's set it to 8. And I'm going to go ahead and get out of here. And I'm going to rerun my docker deploy command. And every time I run this, it's going to look at my definition, which is in my compose file. It's going to inspect what is there, and then it's going to try to make what's in production what I actually asked for. So we're going to let this run. See, it's updating the visualizer, and it's updating the web app. If I docker service ls, I should still see those two. I don't think there should have been a reason for it to kind of change the service thing. So these are still the same instances. They have the same ideas they did before. If I run the ps command on the web app web, which is this, I will see the 1, 2, 3, 4, 5, 6, 7, 8 instances running. So I have 8 kind of desired instances running. If I look at the visualizer, I can see all 8 of them are running here. If I go over to my endpoint, I should see that this is functioning here. And it should be kind of load balancing between the different endpoints. So as I refresh, you'll see it go here. In fact, there's an auto refresh button. Let me just click this. So every second it'll refresh on its own, and you can watch that kind of change. Now, what I want to do is I want to deploy an update. I don't know if the visualizer shows. Yes, you can see it here. So this visualizer shows, can I make this bigger? Yeah, it starts to get a little wonky, but I think you can still get the idea here. So the image for web app underscore web, this image is hello colon 0.3. That's not the latest version. Let's say I just made some major improvements to my application and I want to roll out the next version, 0.4. These are all running 0.3s right now. All these instances are all 0.3s. So now what I want to do is kind of do the same thing as I did for when I scaled this up. I'm going to go back and I'm going to edit the compose file, and I want to go to 0.4. I'm not going to change anything else. So when I rerun this deployment, it's going to see that I asked for 8. There's 8 of them. It's going to try to make sure that they're all running 0.4. It's going to update them 2 at a time, 2 in parallel at a time, and it should be about a delay of 10 seconds between each one. So we should be able to kind of see this update roll through all the containers and do the updates. So that's what we're hoping to see. I'm going to go ahead and get out of here, and I'm going to save this. And I'm going to rerun this deployment command. So right here you can see docker stack deploy web app-c docker compose file. It's already completed here. Let's go to the visualizer. And so you can see briefly, you saw them kind of go down. So now this is running 0.4. This one's running 0.3 still, 0.3 still. This one's running 0.4. This one went down for a second. And now it's back up at 0.4. So you can see it's rolling through these updates and they're coming online. Here's a 0.4. This one's still at 0.3. This one just went off the board. That one just went off the board. They should come back up as 0.4 now. Here's a 0.4 down here. The 0.3 disappeared. This is 0.4. It was, you saw briefly, it was red because it wasn't quite running yet, and now it's green. Once it's green, then it can go and do all the rest. So at this time, it's rolled through all the updates and it's running version 0.4. So that's how you would do like a rolling update. If I go in and I refresh this thing, this is already doing its refresh automatically. Every second, you can see it kind of rolling through the different containers. Okay, so let's talk about a common maintenance problem that we will have. So we have opted into running this Docker Swarm on EC2 instances that we maintain. All right, that means that at some point I have to come into each of these instances and kind of do updates or add patches or whatever I'm going to do. If we look at the visualizer right now, the visualizer really zoomed in. Let me zoom out a little bit so we can see all four. We have 4 worker nodes and the master node. And we can see, for example, this instance has 2 web apps running and this one has, the 2. But if I look for, say, Swarm worker number 2, which is the one I want to update, this is running on 3.36. Let's see if we can find that over here. 3.36 is this one right here. So it's running 2 instances. That's the one I want to kind of drain these instances off of this node. That means that they will kind of disappear from this node. They will get put onto one of the other nodes. Then once it's drained off, I can go in and do my maintenance on that node. And then I can set that node as active and then have it start to participate in the swarm again. So let's go through the steps for that. I still have a terminal window open into the master node. There is a Docker node command, and you can see kind of what the options here. And so the Docker node command, I want to use the ls command. Then I can see, what these instances are all called. And based upon what we did before, this is the instance I want to shut down, which is the 10-1-3-36. So if I look at my instances, it's this one right here. That's the one. I'm going to copy that host name. That's the instance that I want to drain all the applications off of so I can put it in kind of maintenance mode. And so the command I'm going to use for this is docker node, and then there's an update command. And so update, if I do a -- help on this, you can see that there is some options that I can set. And what we're going to do is we're going to set this availability string. Right now, these are all set to availability is set to active. What I'm going to set it to is drain. So that's the command I want to run. So docker node update, and then I'm going to set the availability to drain, and I want to specify the host name, which I already copied, which is right there. I'll just paste it in. So this command should now drain off. Well, we saw them disappear real quick, but it drained off those instances from this node, and it put one here and it put one there, I believe. So now if you look at all the nodes, you still have 8 instances running, which is what we asked for. There's 2, 4, 6, 8, but there's nothing on the node that I need to log into to do maintenance. So now imagine that I've logged into that node, I've done all the updates, I've installed the patches, So now this node is now ready to rejoin or be active in the Docker Swarm cluster. So we're going to go back to our console. We're going to run almost that exact same command, but instead of setting the availability to drain, we're going to set it to active. One of the things that you might think that would happen automatically now is, oh, it would automatically rebalance. So it doesn't automatically redistribute the applications. If I want to redistribute, I have to force that. There is a command for that. So we're going to go back to our console, and we're going to look at our Docker service update, and we'll look at the help on here. And it has a lot of options. You can scroll through and see how many there are, but there is a -- force option. And if you look at what that says, is it forces the update even if no change requires it. So if I were just to run, let me clear out the screen. If I were just to run the deploy again using Docker Stack Deploy web app, if I did do this again, it's going to come through. It's going to inspect that composer file. It's going to see that there's no changes, and it's not going to do anything here at all. So it doesn't quite get us to where we want. So if I can't just redo a deployment to get it to rebalance. First of all, let's go ahead and list out our services again. I have this. This is the service I really want to redistribute and use that node again. So what I'm going to do is I'm going to come in and I'm going to run Docker service update. We're going to use a force attribute, and we are going to force that web app service to update. So when I hit enter here, it's already kind of doing the 8. If we watch it in the visualizer, it's tearing them down and it's build them back up, and it'll redistribute them so that we're using that empty node. So it looks like everything's done, but it's not quite done yet. So it's still tearing stuff down and building them back up. And again, it's doing them 2 at a time and giving 10 seconds in between. So you can see it's kind of done these 6. Now it's on to the last 2. And every time it does it, you'll see them kind of turn red here, and then they'll repopulate. So now when everything is said and done, it should have redistributed all of our application across all those nodes. So when I tear one down, I have to kind of go through that extra step to make sure that everything's being repopulated. Okay, so we've pretty much accomplished all of our topics that we wanted to talk about, except for the last 2. We've built up this kind of infrastructure where, we have a total of 5 workers. We actually don't have one of these. We had 4 workers and 1 manager/worker. We built up that infrastructure. We kind of went through how the Docker daemon was installed using the user data. So we did that. We configured a manager, and we configured all the different workers. And we went through kind of manually deploying a container. And we also saw how to kind of do it using a stack. If we go through the topics again from the top to bottom, we created the instance, Docker Swarm master nodes, manually created the service. We created the service using stacks. We showed that there was a monitoring service that we could create, so we could actually visualize some of those nodes and where they're created. We talked about draining a node. We talked about deploying rolling update. So let's talk briefly about high availability. If you're going to use Docker Swarm for your production app and deploy this to Amazon EC2 instances like we have here. Okay, so a couple of things here. We have a single point of failure with this manager service. We have a single EC2 instance that is behaving as our manager. Docker Swarm supports multiple manager instances. So we would want to absolutely have multiple manager instances, and I want to deploy them across multiple AZs. So that would increase the resiliency and the availability for this infrastructure. Same thing goes with my worker nodes. Right now, I have them all deployed to a single public subnet, and that was just mostly for convenience for this example, but we would want to deploy those across multiple availability zones to make this thing more available. One more thing that you would want to address is all these EC2 instances, I spun up T2 micros just so I could keep it in my free zone. However, you would want to size these EC2 instances so they could do the work that you wanted them to do. Based upon how many how many containers you think they're going to run, you need a certain amount of CPU and a certain amount of RAM to support, those applications. So you want to size these EC2 instances for what you would need in your production environment. Finally, I want to touch base on that this is a Docker Swarm tutorial. There are other orchestration tools, like for example, Kubernetes by Google, and there's also other options for us to deploy. I don't have to deploy all this manually to the EC2 instances where I maintain those instances. I can use Amazon ECS or Amazon EKS and have those instances, be managed by Amazon. So I don't have to drain a node to keep it up to date, Amazon will keep those up to date for me. So my plan is to cover those options in future videos. I'm not sure which order they're going to come out in, but I think the next one will probably be the Kubernetes video. So if you like content like this, hit that like button and subscribe. We'll see you next time.